Okay, so warm welcome again to our webinar about plastic circularity market, which is a very powerful topic for today. And I just want to hand over to Luciano, who is the master for this topic today, and I will be your moderator, and I will take the questions at the end of this webinar. So, Luciano, warm welcome, and the stage is yours.
Thank you, Mario. And thanks everyone for joining. Welcome to this webinar. As Mario said, today we're going to talk about plastic circularity market. We're going to share with you some trends and opportunities that we see. Let me first start with our approach here in Europe. How are we doing these studies? We finalized a study on decarbonization technologies for chemical industry, and now we started this study on circular economy. Following the same approach, our first step is to contact end users and solution providers, people that are directly involved, in this case, to the circular economy on plastics. Together with the end users, we discuss what are the challenges and the technologies that they are looking for, and based on that, we will define the scope of our study. We then go and contact and reach solution providers and have briefings with them and trying to understand what are their solution capabilities in terms of the scope that we define with the end users. And based on that, we do a market analysis. We develop a quantitative market size analysis and a qualitative research, which is called the Champions Radar. The studies are then shared with the end users that contributed to our initiative. And we will promote these documents through different events like AGEMA, our own ARC forums, or other events. And we're going to sell these documents to anyone that is interested to get more information about this topic. We can use this research to advise end users on how they show their solutions, how strong they are in relation to the topic that we are covering. And we can also advise our solution providers in terms of how strong their solutions are, and we can advise end users sharing information about solution providers, what kind of technologies they share, giving more detailed information about their solution capabilities. So this is the agenda for today. We have 30 minutes webinar. And we will start explaining the value behind circular economy and why should we invest on it. We will then explain how is the industry moving forward on this journey. And we will also share with you the first challenges and solutions we discussed with asset owners involved in this industry. And we will finalize with some reflections and also share with you what are the next steps for ARC on this topic. So let's start talking about the value behind plastic circularity and why should we focus on it. I think we all agree of the severe effect that plastic waste has on health and environment. We can start with the microplastics, with hazard chemicals that are found in most tap water. They are found in our blood and even newborns. Humans are believed to consume the equivalent of a credit card every week on microplastics, and the main source of it is the degradation of mismanaged plastic waste. On the other hand, mismanaged waste incineration is a high concern, especially in low-income countries, as it is related to a global mortality of more than 400,000 people per year. Maybe the most evident effect on plastic waste is related to wildlife, and especially in the ocean. So according to National Geographic, millions of animals are killed annually by plastic waste. And finally, plastic industry has also a relevant role in the global warming, emitting billions of tons of CO2 equivalents per year to the atmosphere. And keep in mind, all of these effects I'm showing you here are referring to the current situation, but what can we expect for the upcoming years and decades? So, according to the OECD, the global plastic production will increase almost 30% by 2030 and double by 2050. And if we continue like this, plastic waste will also grow at the same rate and will also double in 2050. Now, on the other hand, if the global ambition policies are achieved, we will save millions of tons of plastic waste by 2030 and billions by 2050. So, what about from a business perspective? So how does a virgin resin compare to its recycled equivalent? The comparison is challenging. It depends on the type of plastic, the required performance of the material, and as well the recycling process. But let's use a couple of examples to understand the business benefits and limitations, considering the product price, the energy consumption, the product quality, and the potential to scale. So the first process I would like to describe is mechanical recycling, which is the most widely used and well-known recycling process. The cost of recycling LDPE or polypropylene, for example, tend to be cheaper than virgin ones. Mechanical recycling also requires much less energy than the standard process. On the other hand, the product is usually downcycled, and it is so sensitive to the type of waste and level of contamination that it will be difficult to scale it up in order to change the growth rate in global waste production. The second process I would like to describe is the chemical one, the pyrolysis, which is, I believe, the most used chemical recycling process at the moment. As opposites to mechanical recycling, pyrolysis oil tend to be more expensive than its virgin counterpart, so the standard oil. And it is also requiring a higher level of energy. On the other hand, we can obtain products with similar characteristics than the virgin ones, as there is no downcycling, and it can process plastic waste that mechanical recycling can't. So, just to keep in mind, both processes are complementary and needed. Now, considering the mechanical recycling will not be able to cover all the type of plastic waste, and the chemical process tends to be more expensive than the standard one, how are we moving forward to reduce the growth rate on plastic waste? First of all, in order to change the growth rate of plastic waste, we should not limit ourselves to recycling. Actually, recycling is one of the latest stages on a circular approach. So the aim of a circular approach is to minimize the waste that is generated. So in order to do so, it starts at the product design stage. Companies should look for new designs with better materials, extended lifetimes, higher level of maintainability, higher level of reutilization, refurbishment, and so on. Recycling is actually one of the latest steps in the circular approach. We even need to consider how are we going to treat that waste that is not even possible to be recycled, even through the advanced recycling processes that I will show you in this presentation. So what about the role of government here? In order to push the industry towards a more circular approach, the government plays a crucial role to create more systemic and structural changes. And here I'm showing some examples on how governments are pushing the industry to move forward. In Europe, for example, there is a circular economy action plan, which includes limitations to utilize single-use plastics in packaging and is pushing companies to gradually increase the percent of recycled materials in their products. In the United States, on the other hand, we usually hear how California is leading in terms of sustainability, and in this case is not the exception. Similar to the European Union, it has passed a law to gradually increase the percentage of recycled materials in liquid containers. On the other hand, China, which is actually the largest producer of plastic and plastic waste, is also moving towards a more circular economy. An example of this is the national sword policy that stops the importing of waste and the utilization of single-use plastics. There is also a memorandum between European Union and China, which is setting up a blueprint for a circular economy approach between both of them. So these are just some examples of how governments are creating new laws, more stringent, to push the industry to further develop in this direction. In order to respond to these policies, companies need to react quickly and together, and the main strategy should be through business ecosystems. An example we can bring is the R-cycle ecosystem. So the objective of this ecosystem is to bring a standard to add watermarks to packaging, which will link to a digital passport. And through these initiatives, it will be much easier for waste collectors to identify those materials that are suitable for recycling, that can be sent then to or mechanical recycling or this solution that I will show you later on, or to chemical recycling that just mentioned. Now, what about the different processes out there to recycle fossil-based plastics? So here's a small summary of the different processes we are focusing in our study and the companies that we have been able to reach and to explore what kind of processes they are using. The first one is mechanical recycling. As I mentioned, is the most widely used process, but it's very limited to the type of waste, and is quite sensible to the level of contamination of that waste. Plastic bottles is a clear example of the type of waste they process. It can produce the plastic product again, is less energy intensive, and as I mentioned before, is cheaper than the virgin counterparts. On the other hand, the product capability is usually downcycling. Now, physical recycling is another advanced recycling process. It's also called dissolution, and it uses solvents to process a wider variety of plastics that cannot be treated by mechanical recycling. It can deal with more complex plastics like those in textiles or plastic with food contamination and even PVC. On the other hand, it requires high capital investments and it has limitations related to the solvents. So there is no a unique solvent that is applicable for all type of plastics. So they need to choose the right solvent for each application. And there are also some environmental issues related to the disposal of that solvent. So companies are also offering a way of reutilizing the solvent, but this is still a challenge. And finally, we have the chemical recycling. There are different types, and the ones that I'm mentioning here are pyrolysis is the most widely used. According to our study, it represents more than 70% of the chemical recycling plants currently. But we also have other ones like gasification and depolymerization. So as I mentioned, chemical recycling can deal with even more complex and contaminated plastics, but is more expensive and requires more energy. It also encounters an industry that is risk adverse and reluctant to use new feedstocks. So to keep in mind, at the end, we believe that all processes are not competing with each other, and are needed as they are complementary. So now again, from a business perspective. So how does the global share looks like, and what can we expect to happen in the upcoming years? According to Plastic Europe Consortium, today more than 90% of recycling is through mechanical processes, followed by bio-based materials and then by chemical recycling. According to OECD, global recycling is expected to have an average growth between 5 and 9% for the next 5 years, depending on how well adopted are the global policies. And finally, in Europe, chemical recycling is expected to have an annual growth of 60% until 2030. It has the objective to reach a capacity of 2.8 million tons per year. In order to achieve this, European companies are planning to invest more than 8 billion euros until 2030. Now, what challenges and solutions did we find? I would like to share with you some of the challenges and the solutions we discussed with end users and solution providers working in the plastic circularity value chain. The first challenge, and especially shared by small and medium enterprises, is related to the lack of fundings. They are struggling to get the right amount of money in order to develop their plants. And what's the reason behind this? A chemical recycling plant between a pyrolysis plant, for example, between capacity of 8 and 10,000 tons per year, will require around 5 to 7 years to design and install. It means that investor will start to get money after 7 years. So this is why they are looking for more short-term returns of investments, such as, for example, digital technologies, that they can see some returns in the first year. At ARC, we'll focus more on the technical challenges and the technologies that are helping the industry to move forward, because then we're going to evaluate, as I mentioned, the solution providers and their solution capabilities to support end users. So the first challenge is related to the product design. And as I mentioned, is one of the most critical steps in the circular economy approach. And the idea is how to make improvements in order to minimize the waste on the products. So we need new designs and we need new materials. And in order to do so, we are considering technologies such as product lifecycle analysis softwares, product carbon footprint calculation softwares, and also solutions related to chemical research and development. The next challenge that we discuss is related to traceability of recycled materials and how to ensure the right fit to the recycled facilities. As I mentioned, all three of them at different levels are sensible to the type of waste that is entering the plants. So it's key to have a strong and robust solution for this. So in order to achieve this, we're going to consider solutions related to supply chain and digital passports as well. Business ecosystems and data sharing platforms will play a key role as well. There is also a need to increase the efficiency of these processes. So the industry needs higher level of automation, higher level of digitalization, and open automation. So we're looking at cutting-edge distributed control systems, advanced process control systems, digital twins, and process simulation and optimization software, which we believe will play an important role in this matter. And finally, as mentioned, the advanced recycling processes such as dissolution and chemical plants tend to be high energy intensive. So any solution related to energy efficiency will have a big impact. So we are looking at energy management software, smart energy meters, like some examples of solutions for this. And then I would like to share with you some reflections based on these first outcomes. The first one is related to the cost, the environmental cost. So based on what we saw there, especially for chemical recycling, which tends to be more expensive than the virgin materials. So as long as virgin plastics do not account for the full environmental impact, it will be quite challenging for recycled plastics to compete economically at larger scales. So we estimated that carbon taxes should be at least double. And keep in mind that today it's around $30 per ton of CO2. And we are thinking on doubling to 60 as an average worldwide. So the next one is related to policies. So regional policies are not enough. So we need further collaborations between countries, as the one we saw in European Union, between China and European Union. But we see some other countries like US, where we see some different level of maturity, like the one in California, that we don't see in other states. We need new funding schemes, especially to empower small, medium enterprise, which for sure will play a key role to reduce global plastic waste. We need business ecosystems and robust and secure platforms to share data. And cybersecurity will play a key role there. And for sure, the technology is there to optimize processes and enabling to scale up the production. We just need more investments and further development on these processes. So let me share with you what are our next steps in ARC Europe. First of all, we're going to release a strategy report by November. Well, we are already finalizing November, so early December, where we are going to share much more details on these first outcomes from the research. These kind of studies are available for everyone that has advisory services with ARC. We will then develop the champions radar. So we are already reaching solution providers and evaluating together with them their solution capabilities, the level of experience for each of the technologies that I mentioned before. We're going to represent all these in a radar like the one that I'm showing you here, and we're going to develop a new strategy report, but focusing on the outcome on this study. We are going to perform a new webinar showing highlights from the Champions Radar study. The webinar will be open to everyone. The same we are doing this one. So you will get the invitation for that webinar as well, especially if you register to this one. In May, we are planning to have a session on circular economy. So we are bringing end users, solution providers to share use cases and to show how the industry is moving forward in this challenge. We organize these events every year. It's in Sitges, Barcelona, and next one will be in May 2025. We're going to perform further studies depending on specific requests. So as I mentioned at the beginning, if you are a solution provider that wants to share with the industry the technologies you are offering related to circular economy, we can help you on that. If you are an end user looking for specific technologies, you are working with, for example, chemical recycling plants, and mechanical recycling plants, then we can help you to scout for new technologies, trends in the industry, and bring this information to you. And we can also develop similar studies to other topics depending on the request. So, and yeah, we're almost finished, and we are here if you want to make any questions, and we keep in contact. And thanks, Mario.
Okay, thank you very much. Well on time. I received a few questions. Are you ready to take them? Good.
Yeah.
So, which recycling process do you think will play the biggest role in the circular economy?
So we see that mechanical recycling is the most widely used. 90% is mechanical recycling. But we are also perceiving a huge development on chemical recycling. There are also big projects here in Europe, for example, with dissolution. I don't think will be one process that will be the most critical one. I think we need all of three and even more. There will be plastic waste for everyone to treat. They are complementary. So mechanical recycling is the cheapest one, but it's limited to the type of waste it can treat. So then it can work together with a dissolution physical plant that is treating other type of materials that mechanical is not able to process. And then we have chemical plants that are treating even other more complex plastic wastes. So for sure, we need the three that I show in this presentation.
Okay, there's another one. What is limiting the growth of this industry?
One of the factors that is limiting the growth is the funding. As I mentioned, small and medium enterprises are struggling a lot to get money to develop, to fabricate, to install their plants. As I told you, for example, private groups, they are looking more for short-term return of investment.
Mm.
And it's also related to, there are doubts about the policies that are being developed. There are some experience with other similar policies related to sustainability, where the industry found a workaround the policy. So if this happens also to the circular economy, then all these huge investments they will be impacted for sure. So I think the main factor is uncertainty related to policies and the fundings that are available for this.
There's a last question about, of course, artificial intelligence. So how do you see the usage of artificial intelligence and blockchain technologies for this industry and for those solutions?
So we are considering these technologies in many of the technologies I show you. We will consider, for example, the utilization of artificial intelligence as a kind of next level of solution capability. So, for example, if there is a company that is offering an energy management software, which is powered by artificial intelligence, then we will consider this as a next level of technology. Blockchain is also playing a key role, and especially we see this on the supply chain and with the digital passports. This is something that I mentioned also during the presentation.
Okay, so we are almost on time. Thank you very much, Luciano, for your presentation, and to the audience for joining us. Let's take the time next time to see each other, and bye-bye for this time.
Thank you. Bye-bye.